Table partitioning is a powerful feature to optimize the performance of data load and data querying. This feature is available with almost all the data platform technologies we have available today, and Azure Synapse Analytics dedicated SQL pool is no exception here. I'm Arshad Ali, and in this video, in the context of Azure Synapse Analytics dedicated SQL pool, I'm going to walk you through table partitioning, how it works, and helps in both data load and data querying, and finally what are the important considerations for using this feature in dedicated SQL pool in particular. Table partition facilitates data lifecycle management and improves the query performance by way of partition elimination. With table partition, data gets divided into multiple chunks, which we call as a partition, where each partition can be managed separately. In most cases, table partitions are created on a date column, which is closely tied to the order in which data is loaded and/or filtered during query execution. Table partitioning is supported on all types of tables in dedicated SQL pool we have discussed in our last video, like cluster column store table, a table with cluster index or heap, as well as all types of distribution, whether it's a round robin distribution or hash distributed distribution. Let's understand this with an example. Let's say we have a large fact table for sales transaction data, and the data that we have here is in billions and it spans across multiple years. Let's say for the simplicity's sake, we have 3 years of data in this table, 2007, 2008 and 2009. When we look at the query pattern, what we see is most of the queries are based on most recent data. Basically, like most of the time we'll be querying the data for 2009 only. And even though we are querying the data for 2009, the queries are going to touch the data for entire table before it can apply the filter to filter out the data for 2009. Right? So that's where the query performance is not optimized in that sense. So that's about how the query performance is getting impacted if we have a very large table with all the data accumulated in a single table with no partition. The other thing is, like when we talk about data lifecycle management for a table, it becomes very difficult. For example, let's say if we want to load data into this table, if we are loading large volume of data, the engine has to take table level locking to kind of start inserting the data into the table. Now, based on how big the data that we want to insert into the table, that can span across several seconds to several minutes, right? So that's a challenge when we are loading data into this table. The other challenge is, say, for example, we want to maintain a sliding window for the data, in which case we want to keep data for last few years only. And in that case, what we want to do is we want to get rid of the oldest data from the table when we entered into the new year or new phase of the data cycle. So deleting that data, you can run the delete statement on the table by putting a filter to delete the older data, but that delete statement is going to take time. It's going to do the row by row level delete on those data, and it's going to take a long time. It's going to put a stress on your transaction log as well, and the performance is not going to be optimal. During that time, your table is kind of unavailable for read query because there is an exclusive lock on the table. These are some of the challenges that we have with when we store all data for a table in a single table structure without doing any partitioning as such. What we can do in this case is to optimize the performance of your data querying or data lifecycle management is do the partition on the table. With that, we can define the partitioning logic based on our need. It could be daily, it could be weekly, it could be monthly, or it could be yearly. For simplicity's sake, again, let's consider we are trying to do partition on yearly basis. And in this case, we are going to create a partition for 2007, 2008, 2009, and then eventually there will be another partition for 2010 and 2011. With this partition in place, let's understand how data insertion or data deletion of this table are handled, or basically how the data lifecycle management works in this case. Let's say we have incoming data for New Year coming in, and that data is for 2010. We insert that data into an intermediate table. Let's call it as a staging table. We insert all that data into that table. And again, based on the volume of the data, it could be several seconds to several minutes to insert data into this intermediate table. From there on, once the data is loaded, we can switch in the partition and move that partition to our main table. This partition switching is a metadata operation, in which case it's going to be almost instantaneous, unlike the previous case where the table was kind of blocked for the duration of data load process. So in this case, our staging table is blocked, which is kind of separate from our main table when we are loading the new data into that table. And then once data is ready into our staging table, we simply just switch in the partition to our main table, and that data is now available in our main table. So this is about bringing new data into the table. Now let's look at the other scenario that we have where we need to delete the data from it. Let's consider that we want to maintain a sliding window scenario here for last 3 years of data. With that, what I mean is we want to maintain last 3 years of data in our table. So basically now, because we have the data for 2010, we no longer need data for 2007, and we can remove that data or archive that data. To do that, what we do is basically we simply switch out that partition to another table, which is kind of another staging table, and this partition switch out is a metadata operation. So it means your table is going to be, this operation is going to be kind of running in almost instantaneously. Once you have this data into your intermediate table or a staging table, you can either delete it or you can archive this data as you see fit for your business requirement. So this is how data lifecycle management works, to insert new data into it and delete the data which is already there in the table. In order to create a partition table, we need to define the range partition for that table. And with that, we do that by defining the boundary points for the range of values that we are going to have. So there are 2 ways to do that, and the very first one is range right, and the second one is range left. With range right, it means the boundary value falls to the right side of the partition. For example, say we have 4 boundary points as we see over here. We have the very first boundary point for Jan 1st 2007, then we have next boundary point for Jan 2008, Jan 2009 and Jan 2010. If we use range right, and we are saying that the boundary will be on the right side of the partition, in the right side of the partition. So it means the very first boundary point is Jan 1st 2007. That value is going to be on the right side of the very first partition that we have. So basically this is going to be falling into the second partition, and any value less than that will come into partition 1. So any record where the boundary point is less than 1st Jan 2007 will come into partition 1. Any value greater than or equal to Jan 1st 2007 and less than Jan 1st 2008 will be part of partition 2, and this is because Jan 1st 2008 is another boundary point. So this is going to be in the right side of the boundary that we have here. So this is what we see for the third partition. All the values greater than equal to Jan 1st 2008 and less than equal to Jan 1st 2007 will be part of partition 3. Likewise for partition 4, and any value greater than Jan 1st 2010 will be part of partition 5. So this is what we see. For a given boundary points, the number of boundary points that we define, the number of partition is going to be the number of boundary points plus 1. So basically we have 4 boundary points here and we have 5 partition getting created over here for for the data in this table. And the same goes with range left. The only difference with range left is the boundary value falls onto the left side of the partition. So that's the only difference. In most of the cases, you will see range right is being used for creating partition on the table. With that, it's time to look at some practical examples of how partitioning works. So for that, let me create an external table which points to a data lake store to read data from data lake. This is part of Polybase feature where we can create an external table pointing to a data lake store to read the data from file sitting on that data lake store and query it. To do that, let me execute this command. This is going to be creating my external table. Once this is done, I can use this external table to select data from this external table, and I can create an internal table here. So in this case, I'm creating a table by using the create table command, and I'm creating this table as a hash distributed table on product key. So let me execute this command, and based on the data that we are reading from the data lake store to load into this internal table, this might take few seconds to few minutes. And for now, like, this query has executed for me. Let me go and look at some of the stats that we have from this query. So if I go ahead and execute this command, I'll talk about the differences between these different queries. Let me execute this and look at the data that we have in this internal table that we just created from the data that we had on data lake store using Polybase external table. So the range of data that we have here is Jan 1st 2007 to December 31st 2009. So we have 3 years of data into this table, and that is what we can see here: 2007, 2008 and 2009. And we can see that for 2007 we have almost 4 million rows. For 2008 we have 3.6 million rows. For 2009 we have close to little over 5 million rows. So this is the data that we have in our internal table we just created by importing the data from data lake store. Now if you notice, we created this table as one single table without specifying any partitioning logic, right? So you see this, we are just saying create table, specifying the distribution, and because cluster column store index is a default in Synapse SQL pool that gets created as part of this table. However, there is no definition for creating any partition. So basically there will not be any partition on this table. In order to create a partition table, what we do is we specify a create table command. We specify the table definition by including all the columns, their data type and all those things, and then we come to with clause where we can include cluster column store index to specify that this table is going to have cluster column store index. Then we specify the distribution. So in my case, I'm creating it as a hash distributed table on product key, and then I'm using the partition clause to define my partitioning information. So in this case, I'm going to do the partition of data on date key, which is one of the column in my table. That is what you see over here. And I'm saying range right. So it means the boundary value will fall into the right side of the partition. So basically with that, if you can see, we have 4 boundary value defined over here, or 4 boundary points defined over here. So it means there are 5 partitions going to be created. The very first partition will have all the data less than Jan 1st 2007. So this Jan 1st 2007 will be part of second partition. So any data greater than or equal to Jan 2007, Jan 1st 2007 will be part of partition 2, and less than Jan 1st 2018, that is going to be in partition 2. In partition 3, it's going to be Jan 1st 2008 greater than equal to and less than Jan 1st 2009. So this way, this is going to be the fourth partition, and finally the fifth partition where you'll have the data anything greater than Jan 1st 2018. In our case, because we have data for 2007, 2008 and 2009 only, we'll have 5 partition. The very first partition will have no data because we do not have anything less than Jan 1st 2007. Likewise, the last partition, the fifth partition, will have no data because we do not have any data where we have date key greater than Jan 1st 2010. So basically, with 4 boundary points, this table will be created, and there will be 5 partition getting created over here. So this is an example of creating a table from scratch where you do not have data already loaded in the table. You just create the table and then you insert data into this table. So this is one way to do it. The other way is, say for example, you have a table with all the data in it, and you want to create another table, or basically you want to partition the data of that table, right? So we created this fact table, internal fact table earlier in the demo from an external table, and this is our non-partition table, right? And what we want to do now is basically we want to create another table with partition and load this data from that table, right? So to do that, we can use CTAS statements, create table as selected statement. That's one of the fastest way to recreate a table with partitioning information. So in this case, we are saying create table, name of the table, and then again cluster column store index is something that we want to have. Anyway, it's a default, and then this table is again going to be the same as distributed as the base table or the source table. And this time we are specifying the partitioning information. So this partitioning information is same as the previous one. So basically there will be 5 partition created based on 4 boundary points defined over here. And because it's a range, right, the one boundary value will fall into the right side of the partition. So let me go ahead and execute this command, and now we can see that our partition table has been created. At this point, because we just created this table, it's recommended to create statistics on this table for optimal performance. Now let's go to the next part of it and look at the details for it, right? So again, if we go back and run this query and look at the data that we have in this table, this is what we'll notice. We have 3 years of data, 2007, 2008 and 2009, and we see the same number of rows from the earlier one. It's just that this is a partition table. Now how we can look at those different partition? We have another query to look at that, right? So to do that, let me execute this command and I'll explain this query. SQL Pool provides different system views to query the different metadata for all the objects that we have in SQL Pool. And one of the system views that provides the information about partition is DMPDW nodes DB partition stats. So this is the one view that provides all the information related to partition, number of rows in that partition and all those things. With this, I'm actually querying the metadata information for my table and its partition. And to do that, what I'm doing is I'm specifying the name of my table to filter all the records for other tables that I have in the database. So this is the table I created as a partition table, and this is the command that I just executed. And if we look at the result that we have got, this is what we see, right? So for partition 1, we have 0 record because we do not have any record where date key is less than Jan 1st 2007. Likewise, if you see partition 5 is again empty because we do not have any record greater than Jan 1st 2010, right? And we have data for these 3 years, 2007, 2008 and 2009, and that is what we see. 2 is 2007, 3 is 2008 and 4 is 2009. So this is the data that we have in the table and each partition on that table. Now let's look at a scenario of deleting the data from a table. And what we are going to do in this case is, instead of going and running a delete statement on the table itself or main table itself, we are going to use partition switch out. And to do that, the first thing that we have to do is create an empty table with the same definition of as our source table. So we have our main table or source table from where we want to delete the data. We need to create an intermediate or a stage table with the same definition of our source table, right? So this is our source table in this case. This is the partition table that we just created, and I'm going to use set as a statement again in this case, specifying all the attributes of the table, and then I'm going to do a filter where 1 is equal to 2. So it means this command is going to create an empty table with the same definition of my partition table, right? So let me run this command. So this command has executed. The one difference that you see over here is for partition, I just have a specified only one boundary points, right? So when we are switching out a partition, we can partition data out to any table irrespective of whether that table is partition or not. If it is partition, it has to be in the same it has to have the same boundary point as the source table. So in this case, because I want to switch out the data for 2007, I have this boundary point defined over here for 2007, right? So in case if you do not want to have this, you can omit this from here, and the data will be switched from your partition table to a non-partition table. This is fine for switching out the partition. However, for switching in the partition, there is a strict criteria where we have to same partitioning boundary defined. For deleting, it's fine to have this switch out to a table which is non-partition. So our empty table is created. Now if we go back and look at the definition for this empty table, because we have only one boundary point defined over here, we will see two partition for this table. And at this point of time, because we do not have any data loaded into this empty table, right, we would see that these two partition have no row count in it, right? So it has 0 rows over here. Now in order to switch the partition from our main table to this empty table we just created as a stage table, we use alter table command on our source table, right? So we say alter table and name of the table from where we want to switch out the partition, and then we specify the switch keyword and partition keyword to specify which partition we want to switch. So if you remember from earlier, we have 5 partition. Partition 1 is where we do not have any data, and partition 2 is where we have all the data for 2007. So what we want to do here in this case is we want to retire data for 2007, which is in partition 2, and that's what I'm saying. Switch partition 2 from our source table to this staging table. So in this case, this is the empty table that we just created, and again, to which partition the data should go to. So we created it as a partition table, and we want this data go into partition 2 of our empty table. So this is what we have specified. If you have non-partition empty table, you can omit this command and this will work fine. So this way you can go ahead and run this command, and you see that this is going to run very quickly because it's a metadata operation. So irrespective of how big your partition is and how many records are there in for that specific year, the amount of time it's going to take, it's going to be almost instantaneous, and it's going to be constant, right? So we see that our data has moved out from main table to partition table, and that is something that we can validate it with the command that we have here next. So in this case, if we look at the data for the partition table, you'll see that the data is now from Jan 1st 2008 to December 31st 2009. So we have 2 years data only now in our main table, whereas the intermediate table where where we switched out the partition, it has the data for 2007. So you can see that Jan 1st 2007 till December 31st 2007, the data is here in the switched out partition table. Now if we look at the data that we have in each of the partition of those two tables, the staging table and the main table. So let's go back to the main table query that we had earlier here. Let's go here and execute this command again, and this is what you will notice, right? So you'll notice that partition 1 and partition 2 is going to have 0 row because partition 1 never had any data. Partition 2 had data, but that has been switched out. Partition 3 and partition 4 remains the data as is what it had earlier, right? Likewise, if you go to the second query to query the partition information for our intermediate table we just created, if we look at the row count per partition, you will notice that partition 2 has now the same number of rows as what we had earlier in the main table, 4 million rows, right? So this is how data has moved from main table to staging table. Now at this point of time, this staging table is completely separate from our main table. Based on the requirement, either you can delete this table or archive the data of this table as cold data for later access. Now this is about deleting an existing partition, but how about we create more partition to the table that we have already created, right? So that's where we split the partition. So that's another way to kind of add more partition to the table that we have already created, right? So we defined 4 boundary points and we created 5 partition for that table. Now suppose if we want to create another partition for 2010 data, we have to split it. To add new partition to our existing partition table, we use alter table and name of the table, and then we use a split range command to split the rightmost partition into 2 to add new partition to it. So if you remember from our earlier example, we had last partition which was supposed to get all data greater than Jan 1st 2010, right? So anything greater than that will come into that partition, right? Now what we want to do is we want to restrict the data for 2010 only into that partition, and anything greater than Jan 1st 2011 should be into the new partition. To do that, we have to use a split range and specify the state to add a new partition on the right of the table for all the data greater than and equal to Jan 1st and 2011. So this is how we create the a split, or basically a new partition to that table. If I execute this command executes successfully, and if we go back and look at the number of partition for the table that we have now, at this time you'll see 6 partition coming up over here. So we had 5 already earlier, these were earlier, and this is going to be the 6th partition, and 5th is going to have the data for 2010, right? So the date range is defined here for 5th. Before we go into the next section, let me come back and talk a bit more about this alter table split range command. This worked fine because the last partition that we had was empty. If it is not empty, this command will not work, and this is because we have cluster column store index on a table, and that doesn't allow to split a partition if there is a data into that partition. To do that, or to kind of take care of this scenario, there are multiple ways to do that. The very first one is you can use CT as a statement to recreate the table with completely new partitioning structure, or whatever partitioning definition or boundary points that you want to include, you can include in this new CT as a statement and create that table. So that's the one way to do that. The other way is you can disable cluster column and store index before splitting the range, and then split it, and after that you can rebuild the index to kind of bring it into the optimal state. And finally, the third option is to kind of move that data, the data which is there in your last partition which you want to split, take that data out from that partition to an intermediate table, and then split it and bring that data back into the main table, right? So that's the third option that you can have. So these are three options listed over here. Based on what your preference is, you can pick either of these three to split a range for a partition which is not empty. Now let's look at the scenario of loading new data into this partition table. We just created a new partition for 2010, and anything greater than 2010 will go into the lastmost partition, right? So in order to bring in data into this table, what we are going to do is, or what I'm going to do here in this case is, I'm going to create a table, an intermediate table, and bring in data for 2010. To do that, I'm going to do a little simulation here. So in the table that we have provided as sample data, we have data for 2009 only, right? So I'm going to select all data for 2009 and add 1 year to the date key that we have to make it 2010 data, right? Just a little simulation. It's the same data, but because I'm changing the date, or basically adding 1 year to whatever date that row has, it's going to be all 2010 data. So this is what I'm going to select from my source table, or the sample table that has been provided as part of the sample database, and load into the intermediate table that I'm going to create over here. And at this point of time, if you see here, I have the new right range boundary points defined over here for matching it with my source table. To do that, let me go ahead and run this. This is again going to take some time based on how much data that we have, but notice this table is an intermediate table, so while this command is running, it's not going to have an impact on your main table, right? So data into this intermediate table has been loaded now, and if I go ahead and look at the date range into my intermediate table that I just loaded data into, I can see that the data is there with date range from Jan 1st 2010 to December 31st 2010. So this is the data into my intermediate table. Now what I want to do is load this data into my main table, right? Let me run this command to show you how many partitions are there in this intermediate table and which partition has data. So if you remember, like we defined 5 boundary values, so there will be 6 partition over here, and the 5th partition is for 2010 data, and this is where we see all the data for 2010, right? And what we are going to do is switch in this data from this table, this intermediate table, to our main table. And to do that, we have the same alter table command, but this time our source table is that intermediate table, and then we are saying switch partition 5. So partition 5 is the one which has the data for 2010. We are going to switch that data into the main table that we have, and that data will go into partition 5, right? So at this point of time, if I run this command is just a metadata operation, and this is going to be running very quickly, and you see that this command has executed successfully. This is irrespective of how big your data is in that partition, right? So at this point of time, we have data moved from intermediate table to main table, and we can validate by running this command again. If you come here, you'll see that the data for partition 4, this is for 2009 data, we took the same copy, made it for 2010, and now partition 5 also has the same number of rows as partition 9. So basically the data has moved into the main table. So this is how we kind of bring in new data into an existing partition table by switching in the data from an intermediate table. So this is one scenario where you have empty partition and you just bring in the data from a staging table and switch in the data into that staging table. So this is one scenario. Scenario 2 could be where you have some data already loaded into that partition, or the partition where you want to switch in the data. And let's think of an example of that. In our case, like we had this yearly partition, and typically for transactional system you would run data load every day, if not every hour or every few hours, right? So in this case, for simplicity's sake, let's say we are loading data every month, right? Now we are in June and we have loaded data till April into our main table, and we have to load data for May into the partition table, right? So to do that, what I'm going to do is I'm going to select all the data from my main table using this filter. This is going to give me all the data for 2010 January to April 30th, January 1st to April 30th, right? So this is my existing data from the main table, and combine this data by using union all, right? So we have another table from where the source data is coming in, and this has the data for say May. I'm taking this May data and doing union all. So basically if we combine these two data set, this will give us 5 months worth of data, right? So using this source command, I'm going to create another intermediate table and load this data into this table. So basically this table will have 5 months of data. At this point of time, what we can do is we can simply drop an existing partition which had 4 months of data and switch in this new table which has now 5 months of data. So this way you can incrementally add data to a partition, right? So that's another scenario for data loading into a partition table. So this is how we can create a partition table in dedicated SQL pool. We looked at different scenario. We looked at creating partition table. We looked at scenario of deleting an existing partition and removing the data from an existing partition. We looked at the scenario where we inserted new row into a new set of data into an existing partition. We looked at another scenario where we kind of added incremental data to an existing partition with already data into it. We looked at the scenario of splitting a partition to create more partition into that specific partition table. Now, there are certain considerations when we are working in dedicated SQL pool, and as you know, even before partition are created or we create the partition on a table, dedicated SQL pool already divides each table data into 60 distributed database. And as we know, that default table in Synapse SQL pool is cluster column store table, or basically that's a type of table recommended for large fact tables. And for optimal comparison and performance of cluster column store table, it's recommended we have close to 1 million rows per distribution and per partition, right? Let's look at this detail, and this is what you will notice. So what I'm going to do is, with this query, I'm querying for a given table that we have here, the one that we have created, how many partitions getting created. And if you notice here, for each of the distribution, the number of partitions are getting repeated, right? So basically for each of the database, the number of partition will repeat here. So in this case, because we have 60 distribution and there are six partition on each of the distribution, there will be 360s partition getting created over here, right? And what you see here is the row count in each of these partitions. So majority of them have no value in it, right? So that's not good. The other thing that you will notice is majority of them have very small number of rows into this partition. So that's not good for optimal compression and might not provide right level of performance that you expect. So in this case, you might consider going up in the granularity when you are selecting the key for distribution. So for example, if you are doing partition on date, you might consider doing it on week, or you might consider doing it on a month basis, or you might consider doing it on the yearly basis, right? So that like each of the partition in each of the distribution roughly gets 1 million rows for better and optimal performance. While partitioning can be used to improve performance in some scenarios, creating a table with too many partitions can hurt performance under some circumstances. And this is what we just saw in our examples earlier. Know that before partitions are created, dedicated SQL pool already divides each table data into 60 distributed databases. And because of that, with same partitioning granularity of SQL Server or any other SMP system, if it used in dedicated SQL pool, the number of rows per partition decreases by a factor of 60. That means you have to consider going up in the granularity for creating partition. Day basis, you might consider going up in on weekly basis, or you might consider going up in monthly basis or yearly basis. Having said that, although there is no hard limit on the number of partition or granularity you can define in SQL pool, however, ensure each partition from each distribution has close to 1 million rows for better compression and performance of your cluster column store index. You can also consider using partitioning for data lifecycle management. And as I said earlier, if there is a need for maintaining a sliding window where you want to maintain the data for a specific year in your transactional table, you can use partition that helps you to manage that sliding window scenario where you have incoming data getting added on one side of the table and the oldest data is getting removed from the other side of the table. So that way you can maintain sliding window scenario. Partitioning a table also makes it easy for targeted index rebuild. And with that, what I mean is you can rebuild indexes for each of the partition when you need it. In most of the cases, you have data changing into one of the very last partition or one of the partition which has the most recent data. And in that case, you do not need to rebuild the indexes for all the partition in that table. You can simply go ahead and rebuild the indexes for that specific partition which has the data getting changed. With that, it's time to wrap up this video for now until we meet again in the next video. Thank you for watching. Please do like, subscribe, and let me know your feedback or any specific topic you would like me to cover. In my next video, I'm going to talk in detail about workload management and concurrency, an important concept and consideration when working with SQL pool. Stay tuned.